Hello, this will be a demonstration of Proposition 9 from Book 9 of Euclid's Elements, which says that if numbers be in continued proportion beginning from the unit, and the second term is a square number, then every number after it will also be a square number, or if the second term is a cube number, then all the numbers after it will also be cube numbers. We're given, just like last time, 6 numbers, A, B, C, D, E, and F. These will be continually proportional beginning from the unit, so that the unit is to A, just as A is to B, just as B is to C, just as C is to D, just as D is to E, and just as E is to F. We're also given that the second term, the number A, is either square or it is cube. It can, at least in theory, be both at the same time if it's a number like 64, in which case both parts of this proposition would apply, but we're going to deal with these cases disjointly. So A is either just a square or it is either just a cube. If A is a square number, then every number after it, B, C, D, E, F, and everything after F, those will all be square numbers as well. And likewise, if A is a cube number, then all the numbers after A, which are B, C, D, E, F, and everything after F, those will all be cube numbers as well. Let's begin with the first case where A is a square number. We don't have to do too much work to prove that the number B is also a square number, for it is the third term in a continued proportion which begins from the unit. And the previous proposition 9(8) tells us that the third term in such a continued proportion is a square number. So that because the unit A and B form a continued proportion, the third term B is a square number. Now the number C is also a square number because A, B, and C form another continued proportion. This is just a selection of our given continued proportion. And we know from Proposition 822 that if 3 numbers are continually proportional, and the first is a square number, then the third will also be a square number. So that because A, B, and C form a continued proportion, and A is a square number, both of which come from our given, we can then say that the third number, C, is also a square number. And it is in this way, using Proposition 822, that we would prove that D, E, F, and everything after F, those are all square numbers as well. We would take our continued proportion, slice out 3 number mini proportions out of them, and say, okay, the first number among these mini proportions is a square number, therefore the last one is a square number by Prop 822, and it is in this way that we will prove that every number after A is also a square number. But what if the number A is instead a cube number? Well, the number B would be cube as well, and this would follow in this way. We know that the unit is to A, just as A is to B. This follows from our given, which then means that the unit measures A the same number of times that A measures B by the definition of proportionality, definition 720. We can then turn this into a statement about multiplication by definition 715 to say that A times A makes B. But A times A is obviously just A squared, and so B would be equal to A squared. But we know from our given, at least in the second case, that A is a cube number. And we know from Proposition 9(3) that the square of a cube number is also square. So that because A is a cube number and A squared is B, B is therefore also a cube number. It also follows quite easily that the number C is a cube number in much the same way that B was a square number. Because C is the fourth number in a continued, or fourth term in a continued proportion which begins with the unit, we know from Proposition 9(8) that it is therefore a cube number. So C is cube. We also know in a similar way, but not using 9(8), but instead using 823, that because the 4 numbers A, B, C, and D form a continued proportion, and the first among them is cube, the last among them, D, also has to be cube by Proposition 823. That tells us that if 4 numbers are continually proportional, and the first is a cube number, then the last will also be a cube number, so that because A is a cube number, D is also a cube number. And it is in this way, using Proposition 823, just like we used Proposition 822 in the previous case, we can show that all numbers after A, including E, F, and everything after F, those are all cube numbers as well, which is what we set out to prove. We set out to prove that in this continued proportion beginning from the unit, if our second term was square, everything after it would also be square, and if our second term was cube, everything after it would be cube as well, which is what we set out to prove, which means we're done with the proposition, therefore, etc. QED. Get used to these continued proportions, which start with the unit. They're going to come up a lot within Book 9, and we'll even see them to the very end of Book 9, which is also the very end of Euclid's number theory. These will come up in quite an important way in Proposition 936. But I don't want to get ahead of ourselves, but I do want to end the video with a particular example of what this is going to look like. So last time when we had a continued proportion beginning from the unit in the previous proposition, I did simply the powers of 2. 1, 2, 4, 8, 16, 32, 64, so on, and so forth. In that continued proportion, the second term, 2, is obviously not a square number, so this proposition wouldn't apply to it. But we can generate a similar continued proportion using instead the powers of 4. Because 4 is a square number, it's equal to 2 squared. So let's generate a continued proportion from this. The next term would be 16, the next one would be 64, and we could continue this forever. Now, what this proposition tells us is that because the second term 4 is a square number, everything after it will also be a square number. That's fairly easy to verify. We know that 16 is equal to 4 squared, and we know that 64 is equal to 8 squared. And so we could continue this forever and show that each term is always a square number. So we see that this proposition holds, at least when the second term is a square number. We can also see that it holds when the second term is a cube number, where instead of starting with 4, let's start with 8. That is the earliest or the least cube number of all numbers. And we were to build a continued proportion off of this. This would go 1, 8, 64 again, and it would go 5, 12. Now, 8 is a cube number, as we stated. So what this proposition tells us is that 16, 5, 12, and everything after those numbers should also be cube numbers. That's pretty easy to verify as well. 64 is equal to 4 cubed, and 512 is equal to 8 cubed. And you could show that every number after these in this continued proportion are also cube numbers, so we see that this proposition holds. That's all I've got to say about this one, so I'll end the video here and move on to Proposition 910.